So everyone already knows Stephanie. She's been working with us actually during the summer as a high school intern for Bryophytes. She did a few things here and there. She was jumping around, but she mostly was doing what she's going to talk about today with you guys. And she actually presented us to the Women's Board for the Women in Science program that they have here at the Field Museum. Take it away, Steph.
Thanks, Francie. So I'm Stephanie Maari. I'm a high school senior in Crystal Lake South in the suburbs. And for 7 weeks, I worked as a Women in Science intern in the botany department. And what I did was essentially an exploratory project or continuation of this moss biomonitoring project that used X-ray fluorescence. So just a little bit of background information on why and how moss can be used as a bioindicator. Moss, unlike other plants, has a very unique biology. It lacks roots, so it doesn't perform photosynthesis, which is something we're all kind of familiar with. Instead, what it does, it collects its materials and whatever it needs from the air and the atmosphere. So I think a big relevant topic, especially with climate change and global warming these past few years, has been pollution. So the ultimate goal of this project is to kind of look at if we can find some pollution trends using moss as a bioindicator. So the EPA says that pollution can be seen as particulate matter, which is essentially liquid droplets and solids combined. This is especially common in urban and industrial areas like Chicago, which is important later on. I think we're all aware of the kind of health risks that pollution can expose one to, especially with like lungs and pulmonary issues, but it also can damage our earth. Specifically, it's hazardous to our wildlife and ecosystems. And then just a little bit more, the EPA does list these compounds and elements on the left, sulfur dioxide, nitrogen dioxide, all as common pollutants. When we started this project, we weren't really looking for one in specific. We wanted to just see what kind of elements we could pull from our samples and see how they compare to these. So a little bit more background information just on the X-ray fluorescence technology. This is the process and the machinery we use to get this elemental composition of moss. So just the way it works is the machine will shoot out an X-ray that removes an electron from the sample. And, just due to the way chemistry works, those electrons have to rearrange to get stability. And then from that, an X-ray is emitted, which populates that graph on the computer. On the very side, I don't know if you can see it very well, but that graph shows the intensity and abundance of whatever the sample's elemental compositions are. So this kind of study has been done where XRF technology has been used with moss biomonitoring, but all of these studies have been done outside of the US. So it's really cool that we kind of started it here domestically at the Field Museum. So what I did and what the team did this year is kind of build off previous work. Originally, a few years ago, a team had gone out to Minnesota. They collected this clean moss, brought it back to the Field Museum, prepared it, and they put them in these bio bags on the left. And these bio bags were distributed all across the Chicagoland area for a few weeks. And then those samples were brought back to the Field Museum and analyzed with X-ray fluorescence technology. For my part of the work, we didn't have that kind of time frame, I guess, because it was a 7-week internship. So instead, we decided to use this cool map and just collect based off of these areas of burden and then just bring them back to the Field Museum. So the dark red indicates the highest burden levels from pollution. The yellow is kind of like in between, and then the blue would be the least burden from pollution. Oh, was there anything? Oh, I think we're okay. Anyway, so what we wanted to do is we wanted to have a wide variety of samples. So we collected from Nachusa grasslands, which is about 80 miles or 90 miles west of Chicago. So we're making the assumption that it will be kind of unaffected by industrialization and industry. I collected from Crystal Lake, Illinois, which is about 50 miles outside of Chicago. We had some other ones like Madison, Wisconsin, and then back to that map from the original slide, we had Park Ridge, Illinois, Rogers Park, Hollywood Park, and then Chinatown, which is important to note that it was found in that very dark red big burden from pollution area. As for our methods, we did collect, so that's a picture from our big botany department collection from Nachusa. We brought all of the samples back to the field museum and we put them in a dehydrator for about an hour and a half, and then we dried them, removed all of the soil and excess dirt from them. We prepared to crush them. Some we used liquid nitrogen to make the moss really brittle. Others we just ground the moss. That's what it looks like when it's ground. And then we have these plastic XRF cups that are specific to the machine. So we filled a bunch of cups with all of our samples and then they were ready to scan. So here is just 3 samples results. We have Nachusa, which is in the blue, Crystal Lake, which is in the red, and then Chinatown in the green. It's quite obvious that Chinatown has this big peak of iron. Crystal Lake is kind of in the middle, and Nachusa, as we expected, had very low elemental compositions, just being super far away from industry. But our biggest, most obvious result and takeaway from this is that there's a sharp increase in iron towards the city, and this was also reflected in our other samples results as well. So as some conclusions we can make, as stated previously, particulate matter is a form of pollution. The EPA does define iron as a particulate matter. So it's interesting to see, most specifically, how iron kind of increased in its levels as one went towards industry and Chicago. We still have some questions left. We kind of want to find a reason why there's the sharp increase in iron. We've kind of been attributing it to the fact that there's industry. I think there's been steel mills around Chinatown. We still want to do further exploration on that. Then, as I said before, we did use some liquid nitrogen for the samples, but we didn't do it for all of them. We also had different levels of fill for the X-ray fluorescence cups. Some were halfway, some were completely full. So we want to continue analyzing what is the best method to prepare moss. And then when we went out to collect, we weren't looking for a specific species. So we want to see, does the species actually have an effect on what the graph populates, what kind of elements it does take in. And then finally, if we collect more, we can see what other elements and pollutants we can find in other areas of Chicago. As for the future research, we do want to continue this project. I think it does require a little bit more exploration. And then I think it's also cool that we could probably use some of the herbarium's historical samples, see what happened 20 years ago in the same area. How has pollution changed? What does the industry and urbanization in that area look like now? We still want to continue analyzing the reasons for why there's been a sharp increase in iron. And we actually are currently working on preparing a manuscript that's hopefully going to be submitted and accepted somewhere. I just want to give a big thank you to basically everyone in botany, Dr. Matt Von Conrad, who is my supervisor, and Cozy Evans, who was on the original team, Danny for helping with the presentation, Tom and Zoe for collecting, Amber for also helping the presentation, and a big thank you to the Field Museum's Women's Board, who essentially curated this invaluable experience for me. So thank you very much. If there's any questions, I can definitely answer them. So take it away.
A lot of compliments in the chat, Stephanie.
Thank you, everybody. I really appreciate it.
Oh, there's one question. Did you find the same species of moss at all of your sites?
Well, we actually went through this like 2 weeks ago. I think we looked at the vouchers and saw there were tons of different species that we collected. And even at the same site, even in the same area, the species was different. So no, we had tons of different species. As for how hazardous iron is to our health, I'm not sure about that specific question. I know that lead, ozone, those have specific health risks. I'm not sure about iron though, sorry. And I am considering a career in research, Miss Kate, so thank you.
Yeah, thank you so much, Stephanie. Are you actively continuing the project? Do you have plans to get out there anytime soon, or?
Well, I'm always in contact with Matt, and I think there's definitely an opportunity for me to come back to the Field Museum. So I think we will continue it. I kind of think it would be interesting if we could get samples from outside of Illinois. That's kind of a bigger project, so I'll have to get back to you though.
Great, thank you. We look forward to hearing more.
Thank you.
Any other questions for Stephanie? Not, I'll again say a big thank you so much for sharing your research. It sounds a super impressive project, especially for a high school student. That's an amazing experience to already be involved in. And like I said, the start of, I'm sure, a really great careers. So thanks everybody for coming over. I will go ahead and stop the recording.